In this lesson I'm going to demonstrate how to handle exceptions in C#. If you haven't done so already, please take the time to read the lesson text for Lesson 20 in the workbook. It contains preliminary information that you'll need to know, and I'm not going to cover in this video. To demonstrate how to handle exceptions in C#, I've created a new project called Lesson 20, and I've already gone through the exercise of adding two text boxes, txt number 1 and txt number 2, and a button called btn calculate. And basically all this will do is take the value that's typed into this field times the value that's typed into this text box, and it will multiply them. Now obviously this could be a problem if somebody doesn't enter numeric values. So what I attempt to do here, I'll show you in code, is basically grab the result of txt number 1 times txt number 2. Then I'll display the result in a message box, and then I'll clear out the two text boxes. So let's run the application, and immediately let's break it by typing in some alphanumeric characters, and then click calculate. And notice what happens. I get this Microsoft development environment stops and says an unhandled exception of type system format exception occurred in the MS Core library.dll. Additional information, and this is important, the input string was not in a correct format. So let's go ahead and click the continue button here. And basically what happened is that our application didn't handle the exception, or rather it couldn't deal with the exception. It didn't know anything about the possibility of an exception. And so the exception, when it did happen, it bubbled up to the .NET runtime, and the .NET runtime had to throw up its arms and say, I don't know what to do with this, so it had to stop the execution of the program. And so obviously we would want a more graceful way to handle exceptions so that our users aren't faced with that same .NET runtime exception message, or the fact that the program basically blows up while they're trying to use it. If you were to release an application like this and the first person who tries to use it just inadvertently types in an incorrect value into a field and the whole application crashes, well, obviously it starts to seem like a very unprofessional product, that it's unstable and it's unusable, and they'll probably want their money back, or at least recommend that nobody else installs it on their hard drive, and you certainly wouldn't want that. Now the message that we got was that the input data was an incorrect format, and there's actually hundreds of different messages, or rather different exceptions, that tell us exactly what went wrong and why it went wrong. In C#, we have the concept of structured exception handling, which means that we can test for any number of common exceptions and treat each situation differently based on the exception that gets raised. We can handle it gracefully and even potentially let the user know what the problem is, or just fix it ourselves in our code. And I'll have a good example of how we can check for the different types of problems that could potentially occur within one line of code, and how we can respond differently based on that. But first of all, let's try to fortify this code and make it so that if somebody were to try to use our application, it would at least respond in a more professional way. So let's add another button, and I'm just going to add some code here. Actually, I'm going to copy this code, and we're going to wrap this code in what's called a try-catch statement. And this is the way that you implement structured exception handling in C#. Okay, so let me explain what we're doing here. We have the same code that will be attempted by our compiler, by the C# runtime. Actually, let me get the terminology correct, by the .NET runtime. And if there's any problem within these two lines of code, what will happen is that the exception that's raised will get bubbled up and caught by this catch statement. And we'll be able to examine the exact nature of that exception, or we can just respond to it in a number of ways. In this case, all I'm going to do is just throw up a message box that says there's a problem with your entry. Please make sure you enter numerical data, and then it goes on and resets. So let's run it this time and see what happens. Okay, we'll type some letters in here. We'll click button 1. And this time we get kind of an imposing message here. There was a problem with your entry. Please make sure you enter numerical values. Notice there's a little X and input problem. These are all selections that I made whenever I created this message box. But basically my application can still run now, and I can continue on and try to run it the correct way. So you can see a big difference that I was able to make just by wrapping the questionable code in a try-catch statement. First of all, the application is a lot more stable, and then secondly, I was able to tell the user what their problem was, and how to correct it. You need to use numerical values. Okay, so this was good for a starter. Now let's talk about how exceptions bubble up. Now we noticed that at this level, if there was a problem, it would bubble up to our catch statement, and when we didn't have this in this first section of code, it bubbled up to the .NET Framework runtime. But in the previous lesson, we looked at using layers, and we created a component for our shipping table in our database to retrieve values and then also perform update, insert, and delete functions. And so many times you'll want to bubble up exceptions that happen on one layer, like the business rules or the data access layer, and decide, if you can't handle them, decide on another layer what you'll do, whether you'll report this to the user or log it into a log file or whatever the case might be. So I'm going to add a new component. I'm going to call this Northwind, and I'm going to create a data connection, and we'll just call this con. And let me move this so I can see it a little bit better. And then the next thing I'm going to do is write a method called open that'll just simply open the connection to the database. There's actually quite a bit here in comments, but not a lot of code that we need to look through. First of all, you can see public void open, so we only have one method in our Northwind component. And the only thing it's going to do is try to open a connection to the database. Now, notice here that I have two catch statements. My first catch statement is a very specific type of exception that I'm going to try to handle, OLADB exception. The second catch statement is a more generic exception. So any exception that happens, regardless of whether it's the OLADB or maybe even 1,000 other possible exceptions, we'll handle it in this section of text, of code. And so that brings us to a best practice. If you need to do something differently based on what kind of exception is raised, then check for different kinds of exceptions from the most specific at the top to the most generic as you follow through the code. So if you don't plan on doing anything different, then don't bother checking for specific exceptions. So in this case, I am about to catch an OLEDB exception. Why did I choose this one? Well, I know I'm working with an OLEDB object, the OLEDB connection object, and that it's possible that a connection to the database can't be made for one reason or another. So it's, in my mind, very possible, and I'm going to allow for that within my code. And here I can decide then what I'm going to attempt to do. I can do one of several different things. I can try to handle the problem internally. For example, if there is a problem with the connection, maybe I just need to wait a couple of seconds and try again, or test a secondary connection string, or test a backup database, or something along those lines. If I can't do that, then I might throw this exception and let the caller handle the problem. So in other words, whoever called the open method on my component, I'll let them handle the problem. Or I can just throw a brand new exception that I create from scratch and let the caller handle that problem. So that's the last one is what I'll choose to do. I will create an exception object, a new exception object, and the only thing I'll do with this exception object is just put in a more user-friendly description of what the problem probably was. In this case, there was a problem opening the database. And I could be more descriptive here. But the reason I didn't want to send up a OLEDB exception is because whatever object is calling this Northwind open method, it shouldn't have to know any of the internals, anything that happens inside of this object. So I want to keep it very generic, yet specific enough so they know generally what the problem is. They might think, oh, well, I have my network turned off, or there's network problems, so that's probably why the database can't be opened right now. But at any rate, here we have a more generic exception, and I've chose to just throw a new exception as well, and given some very generic text. Unknown problem with the database. So we don't know exactly what it was, but there was just a problem. Here we know, we at least give a little more information. There was a problem trying to open or create a connection to the database. So now let's do this. Well, here, let me first of all add another button onto my form. And here I'm going to do that open. Okay. So this will call our new open method that we created. The next thing I'm going to do is make sure that an exception happens, and the way I'm going to do that is go to my connection string here, and I'm going to foul up the exception string so that it couldn't possibly open up a file. I'm going to do something very specific. I'm going to find the file name. Let me see where that's at. Here we go. So instead of fpnwind.mdb, I'll just put a 2 right before the .mdb. So since I know that this file does not exist on my hard drive, this should crash our application, or at least cause an exception to be raised. So now let's run the application. Whoop. Of course, I need to fix any problems that we might have here. And I simply forgot a using statement. Okay, now we should be able to do this. Why do I need to include this namespace? Well, for two reasons. First of all, because our connection object is going to need it, but then also our exceptions are part of the namespaces, just like the other objects that are used for given functionality. So you'll find several different exceptions that are available in the OLEDB namespace that relate to OLEDB databases. And you might find other exceptions related to I/O for problems related to opening and closing files and so forth. Let's try it again. Okay, let's click button 2. Now what happened here, we have a catch statement. It should have filtered out the unpleasant messages that we get from the .NET runtime. Well, here's the problem. while we are catching the exception, let's just hit continue here. While we are catching the exception in our open method, we're actually throwing a new exception or raising up the existing exception, either way, up to the layer of software that called this method. So by virtue of the fact that in our button 2 click event, the fact that we try to open and we're not ready to accept the possibility that there would have been an exception, that is why the application ultimately failed. So it's not enough just to implement some structured exception handling. You need to make sure that it's pervasive across your entire application. So here, let's add some code and run this again. And this time what I'll do is use a message box, and then I'll just simply print out the message that's returned or that's thrown, that's associated with the exception that was thrown up from our Northwind layer. So let's go ahead and run this application again, and this time we should see a different result. Okay, so we get a nice message, problem opening database. So let me re-emphasize that each layer should have its own wrapper of try-catch statements to anticipate what might go wrong. So you might be wondering to yourself at this point, why do I need to use exception handling? Or when do I need to use exception handling? What should I wrap the try and catches around, and what should I leave alone? Now, in my opinion, this is actually a little bit of a tough question, but you should look for possible areas of failure within your application. Some code has a low likelihood of failing. For example, I can't imagine a scenario where these two lines of code would fail very easily. But connecting to a database has been known to fail quite often in the past. So with a little bit of experience and forethought, you can ask, what are the weakest links in my application? And wherever you determine those weak links are, you should take great care to include structured exception handling in those areas. Now, database access definitely falls in the category of a weak link in the chain, at least from my experience. So if the database file gets renamed, or if the network is out and you're trying to connect to SQL Server on a different computer, or whatever the case might be, those kinds of things would essentially be showstoppers, and you'll need to handle those situations gracefully. In other words, you'd want your application to respond well to problems and not just collapse, like we saw at the very beginning of this example. Now, in this case right here, why did I choose to display the error message to the user? Why didn't I just throw the exception again, up to another layer? Well, at some point you have to handle the exception, or, as we've seen, the .NET Runtime will handle it for you. The user interface is usually the last line of defense, but it shouldn't be the only line of defense. Each layer in your application, as it makes a call to methods and other layers or components, should gird itself against failure. So ideally, as we already said, we completely hide problems from the end user if the application can take care of the problem itself. But for those items where outside help is required, we might need to tell the user that the application simply can't recover from the problem. Maybe the network connection is down. You'll have to call the system administrator to take care of it. Or maybe you've got a problem on your machine and we couldn't find the files that we needed, or whatever the case might be. Or instead of just popping up a message box and making it a one-way communication, we could actually give the user some options. Would you like to try it again? Would you like to abort this operation? Would you like to try and reconfigure some things and see if that helps? So we can give the user some options and not just tell them that there's a problem and then shut down the application. So in closing, I encourage you to do the exercise for Lesson 21. It's not a coding exercise, but it's a rather research exercise to find as many exceptions as you possibly can. Just look through the help and see what exceptions are available to you. And please don't underestimate how valuable it is to spend some time doing this. It's not as fun as coding, and it's a little time consuming, but I personally gained a lot of insight when I took the time to do this myself. And obviously there won't be a video for this lesson's exercise. Thank you.